lesson, we want to look at sets. Now, the root of any number that leads to an irrational number is always going to be referred to as a set. All right. And also, another thing that we need to take note of that is that for irrational numbers, all that we are saying is that they are non-terminating and non-recurring decimals. So the only numbers that are not sets are those numbers that anytime you pick their square roots, you are going to get a whole number. So look at these numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and so on are the numbers that we refer to as perfect squares. Anytime you pick the square root of those numbers, you are going to get a whole number. So these are some of the examples, and then if you pick the square root of these numbers, you are going to get these results. All right, so why am I even discussing this? I'm doing this because anytime at all we want to simplify sets, we always want to break the set into a perfect square and any other integer. So for example, if we have, let's say, root 7 cannot be reduced. We cannot break it down. So it means this cannot be reduced. So the result is still root 7. Let us move on to the next set. Root 18, can it be reduced? Yes, root 18 can be reduced. Now, root 18 can be reduced in terms of a perfect square and an integer. Now, if we look at these perfect squares here, we realize that we can actually reduce it using 9 by 2. Let me introduce my square root. So 9 by 2 is 18, so I have not changed anything. 9 is a perfect square, and then 2 is just an integer. So what is the root of 9? We said the root of 9 is 3, so I can re-express this as 3 root 2. So this is how we normally simplify sets. For the sake of clarity, let us solve these examples. Simplify the following. Root 20. So root 20 is also a set because 20 is not a perfect square. So it means that the root of 20 is a set. We can break the 20 down. We can break it into a perfect square and any other integer. And that can be done by multiplying 4 by 5, the square root of that. 4 by 5 is 20. So, and 4 is a perfect square. So we can actually reduce this. The root of 4 is 2. So finally, this is the same as 2 root of 5. The root of 5 cannot be reduced, so we have to maintain it. All right, let's move on to the next example. We have root 32. This can also be reduced into a perfect square and an integer, and that is 16 by 2. We all know that 16 by 2 is 32, and 16 is a perfect square. And what is root 16? Is 4. So our final answer is going to be 4 root 2. And this is the 2, what we have here. All right. The next example is root 72. The root 72 can also be expressed as root of 36 by 2. We all know that 36 by 2 is 72. So what is root 36? Root 36 is 6. So that's going to be 6 root 2. And then the final example is root of 125. Root of 125 can be expressed as root of 25 by 5. And 25 by 5 is 125, so I've not changed anything. What is root of 25? Root of 25 is 5. So this will become 5 root 5. I hope this helps.